Hey guys. Wait, let me bring my mic closer. Hey guys, welcome back to episode 8 of How to LeetCode with Jeff. This is gonna be a cool problem. Today we're gonna be solving LeetCode 143 reorder list, and let's jump right into the problem. Okay, so we're given the head of a singly linked list. This list can be represented as L sub 0, L sub 1, all the way to L sub n minus 1, right? And we want to reorder this list. Taking a look at the first example, our input is going to be 1, 2, 3, 4. Excuse me. And we want to be able to do this 1, 4, 2, 3. So why are we reordering it like this, right? At first glance, you might like see like, oh, are we just taking this node, putting it over here, then taking this node, putting it over here, and then taking this node and putting it over here? Well, if that was your guess, you guess that's exactly what we're gonna be doing. We could see in this case, we're just basically taking this half of the list and this part of the list, and we're alternating the nodes from each side. So in this case, they gave us both an even and odd example. Yeah. So excuse me, I'm a little bit feeling under the weather, but bear with me. 1, 5, 2, and then 4, right? And then 3. So why did I choose this problem for our next problem, right? This is because if you were following the series earlier, we did cover how to reverse a linked list, and we also covered slow and fast pointers, also known as the hare and the tortoise algorithm, right? So we're really building our understanding of linked lists over here and playing around with memory references and whatnot. And I think this will be like one of the last problems until we can move on to, for example, a doubly linked list, right? So, um, I can draw a quick example. What we're gonna be doing, let's say we have a linked list that goes, we're just gonna use the example from, shit, excuse me. I did not mean to say that. We're just gonna use a example from the problem statement. So we have 1, 2, 3, 4, 5. We want this to be 1, 5, 2, 4, and then 3 is gonna be at the end. So the way we can think about this problem is the first thing we can do is partition our list, right? So the cool thing about the slow and fast pointers is that we used it to detect if there was a cycle in a linked list, meaning that this node points back here, right? But what was useful about that problem was actually the fact that we knew that if there was a cycle, these nodes would be perfectly split, right? So since the fast pointer travels twice the speed, if we were to move over here by 1, by 2, by 3, by 4, at like 2 iterations, once the fast pointer reaches this, we will actually just cut the list in half. So we're going to be finding in this example the midpoint like this, right? And we'll say, okay, wait, hey, can't we just set this equal to this now? Um, right? And we can definitely do that. However, what's gonna end up happening is that this node over here, this 5, points to null. So if it's pointing to null, we're gonna have trouble when we want to access 4 eventually. So what we're gonna do is we are actually gonna quickly. Ooh, that's not. I don't know why paint is like that. If you guys have any other like tools to use that you guys use the whiteboard, please tell me. But for now, we're gonna be using paint. And it's messed up. But you guys get the point. Um here. Perfect problem that combines both our understanding of reversing references. So now we can actually we're also gonna be setting this to null because at that point we're cutting off this list. So again, we're gonna be first. Step one is, if I can find the right thickness. That's not okay. I give up. But you guys get the point. We're gonna be finding the midpoint. Step one. Step two is reversing, partitioning the list and reversing these links. And then step three, we're gonna be merging it together, right? Okay. In the problem statement, it says that you may not modify the values in the list node. Only nodes themselves may be changed. Because if we could just modify the values, that would make the problem a whole lot easier. But that's not what we want to do. So without further ado, we can jump right into the coding. We can first check if there's no linked list, right? Or this is also null, we could just return. That's like the first case that we might want to check. And this is literally the same code as the cycle code, where we have a slow pointer and we have a fast pointer. We initialize that to start at the head. While fast and fast.next, so while both of these guys have a node, we could increment our slow pointer by 1 and increment our fast pointer by double that. So again, .next. Now this is going to be in the perfect position where we want to start reversing the second half of the list, but we also want to, keep track of that, right? So we will call the second half of the list the start of the second list. And this will be equal to slow.next, because if we land our slow pointer here, we want to take 4 and 5 and then reverse it. So I'm just going to label this start of the second list. We can also take what we're going to be doing for our current pointer, and then we can honestly start to reverse the list, right? And is there anything I'm missing? Yeah, we can also set slow.next to equal to none, because we're going to keep a reference of this pointer, but then we also want to set slow.next eventually to none, so that we're essentially cutting that list in half, right? And how do we reverse the linked list again? While current, we want to keep our friendly temporary variable handy and set this equal to the current.next, so we can save the rest of that linked list, so we can continue reversing however many nodes that there are. So since temp is equal to current.next and we have that saved, we can now set the current.next equal to where prev is, because prev is pointing to nothing, right? I didn't actually initialize prev, so we'll do it right here. Now we're going to be incrementing the prev pointer plus 1 to where current is. So set prev equal to current, and then after all of that, we can set cur equal to the temporary variable that we saved up here. And if that quick explanation didn't make sense, I do recommend you to check out the earlier episode in series where I go over the problem reversal linked list. So now that we have our midpoint, right? We have the list cut in half, and we're ready to sort of alternate these nodes to form our output list. What we want to do is we can take the first and second, the start of all of those lists, and that's going to be equal to the head and prev, because previous is going to land exactly where we want it to land, which is the start of the second part where we're alternating the nodes. Since we're stopping short, right? If it's the even case, we know that it's going to be at 3, and that means that if we have an odd case, it'll always be shorter. So we could just say while current is while we still have a node to run through, excuse me, we will now merge them together. So we can set temp1 and temp2 equal to first.next and second.next respectively. And we're setting first.next. We're taking this. This is we've saved this node in a temporary variable, just like how we would to reverse a linked list. And the concept and the main idea of this is when we're playing around with these memory references, but we don't want to lose the link, we'll just save it and then do what we got to do to connect 1 to 5, right? So we're connecting first.next equal to second. And then now imagine just these two arrows are reversed. We're connecting this one 5 to the temporary variable temp1, which is first.next, which is 2. So after that, I said second.next is going to be equal to temp1. And then after that, we will increment our first and second pointers to temp1 and temp2 respectively. And this should be the solution. Let's run it. And yep, boom, there we go. This is not, I believe there might be a more efficient solution, and we will touch on that in another video. But that is how you solve reorder list. Again, step 1 is finding the midpoint to start reversing the links. Reversing the second half of the list. Step 2, cut the list in half, which was utilizing slow and fast pointers and also reversing a linked list, like I've said previously. Excuse me. Step 3 is building our new list, and then we sort of can visualize it with the 3 while loops that we have here. And we're not returning anything, so there we go. That is how to solve LeetCode 143 reorder list medium problem. I will catch you guys in the next one, so peace.